We have learned um, linear regression and logistic regression, and I have explained little bit about single layer perceptron and multi-layer perceptron, only how we can implement those using PyTorch. Now today, mm, I will explain little bit more about those single layer perceptron and multi-layer perceptron, so that anybody can understand um, um, from mathematical perspective little bit. Okay, I will not go in detail mathematics, but how this neural network looks like, how this neural network looks like, how MLP looks like. I will explain here today. After that, I'll go for clustering, and um, mainly I will explain about K-means clustering. If we get time, we'll go for another clustering named DB scan. Okay, so I'm sharing this um, notebook link, so that all of you can uh, copy and paste and do the do your own. Okay, link copy tested. Okay, so I have shared this one, and please download that one, and uh, mm, open it in your own Google Colab, and open a new uh, collab with empty collab, where you can or empty notebook where you can copy and paste and run those things. Okay, so first of all, mm, what we have learned yesterday, this is a regression technique, and another is classification technique. So for regression, we have used linear regression. Some other regression model are also there. For linear regression, we have estimated only line. Someone can also mm, estimate a curve, which quadratic or biquadratic curve, uh, which will gives better regression. Okay, so I'm not going into detail of that. Now, secondly, we have learned classification, where we have done a binary classification based on students' study time, study duration, and attendant class attendant. Based on that, we have predicted uh, we have predicted the probabilities whether that student will get passed or failed based on that those values. Okay, okay. So um, based on those values, we have predicted whether the student will get passed or failed. Now, as a data point for a single layer perceptron, what we have done, we use same data point, but yesterday we have implemented using PyTorch, and we have used only one feature vector, only one features of each data. Okay, not vector, only single feature we have used. Okay, so as I told yesterday, we should learn to use multiple features. I will try to show those today. Okay. So before that, before going into the um, coding part, I will explain how this single layer perceptron and multi layer perceptron works. Okay. So as I told yesterday, today also I am saying we have the student data where the features are hour of study and attendance. Based on this hour of studies and attendance, we will try to classify whether that student will get passed or get failed. Okay. So, so this is the architecture of single layer perceptron. This is the simplest neural network architecture where no hidden layer is there. So in a neural network, what happens? What it contain? It contains input layer. Where is the that is written somewhere? No. Okay. Uh, one input layer is there. Okay. I'm going into showing this architecture. Then you can get detail. It is a typical MLP architecture. I will explain more on that after explaining that singular perceptron. But for a neural network, typically what is there? One input layer will be there, some hidden layer will be there. There may be one or multiple hidden layer and one output layer will be there. Whatever output we will get, whatever output layer we will get, we will apply a sigmoid function to get to convert those output into probabilities. Okay, these four thing it contain in a typical um, mm, uh, uh, neural network architecture. Okay. So in single layer perceptron, here in single layer perceptron, no hidden layer will be there. Okay. What it will do? It will take the input layer. This input layer will contain the feature of these inputs, data points. Like here it is hour of study and attendance. Suppose it is x1 and attendance is x2, and it will here it will compute uh, and here it will compute, and after that finally after whatever computation will be done here, and after computing whatever result we are getting, we will apply a sigmoid function on that as a activation function, and whenever this sigmoid is applied, then we will get whenever this function applied, we will get the probabilities of that, whether it is student is getting passed or failed. Okay. So someone asked in chat, do we need to learn this architecture? If someone try to learn more about how to implement, how to build more complex architecture, then he or she have to learn this basic architecture. Then only they can proceed for advanced one. Okay. So what happens in neural network while training? It learns some weights. So what is the weights? Here W1 and W2 are the weights. What it means? These weights means the not exact meaning. These weights means it calculates the importance of features. Okay. So with this W1, we can say what is the importance of this feature, and with this W2, what is the importance of this feature corresponding to the predicted value. Okay. So suppose someone studied too much, 16 hour, and his or her attendance is very low. So if neural network learns from the data that attendance importance is too much high and study hour is too much low, then that with that it will calculate and it will predict whether they will get passed or failed. So I am talking about many times this calculation. What this calculation does? This calculation does only this equation, or this for this singular perceptron. What it does? Just take linear combination of those uh, features, and it will add a bias to with that. Okay. So here B is the bias. Bias means what? Like y is equal to mx plus c. Whatever we are learned yesterday, that state line equation we are estimating using logistic regression. sorry, linear regression, like that, we act like that their c, when x value of x was 0, that c's value, we are getting the c value. Here also, if w1, if these x1 x2 are 0, then we'll get that bias value. So where to place that line, it defines by this bias. Okay. So so what it does, it calculate, suppose initially we have considered this w1 and w2 as random value, and it will calculate this with this equation, that z will get z using this equation, w1 into hour of study plus w2 into attendance plus b. Okay. Whatever value we are getting as z, we will apply some we will apply this sigmoid activation function. We will get the students pass or fail, probability of pass or fail. Okay. So as initially we have considered this w1 w2 is as random value, so it will not give the correct probability. So what we have to do then? We have to calculate the error. We have to calculate the error. Whatever we are calculating these from weight and features and bias, we have calculated this value z. This is called forward pass. Okay. Now it is not giving the mm, uh, correct value. So we have to calculate the error. We will calculate the error using just suppose here uh, binary, as we are predicting binary, we can calculate the binary cross entropy loss. Okay, and based on that error, we will update this W1 and W2. Okay, that is called back propagation. Okay, so in second iteration, we have got that new W1 and W2, and based on that new W1 and W2, we again calculate this W1 into X1 plus W2 into X2 plus also that B value of B also will be recalculated, because as I told yesterday that we have to place the line somewhere in that uh, wait, how can I show? Oh, sorry. Okay. I'm drawing a line again. That line is not there. I'm drawing again. Okay, so here suppose this uh, C we have, as I told yesterday, this C value we have to calculate, we have to predict, estimate. Here it is, I am saying that B value uh, is the bias. This C corresponds to that B. Okay. So if this C value is increases, then and slope is the same. Suppose C value is like this, then line goes like this. So based on this C or C1, we can shift those lines. Okay, like that. Here we have to calculate that B value also, bias also. Okay. So it is very simple neural network, most simple neural network. Uh, we have to learn this one for basic stage, though it is not that much efficient, as it only estimate like it only estimate a line. For complex data, it will not give a good result. Okay, so I here I have implemented these for two feature. Yesterday I have implemented those with a single feature, and now I have implemented those using two feature. Means one is hour of study and another is marks. Based on these two feature, we will um, train the model. Okay. Here epoch is number of iteration, nothing extra. Number of iteration, how many iteration you are running that uh, code, that is called epoch. Okay. So I have imported all those libraries. Now this is the data where I have used that two features. X contain these two feature, uh, which yesterday we have added only one feature. Number yeah, only one feature, attendance. Based on attendance, we predicted that one yesterday. Now today I have used study hour and attendance both. Okay. And why is the whether student will get passed or failed. Okay. Now, as we defined yesterday, we will define the same model here. We are using that linear layer from that PyTorch, PyTorch nn dot linear. We will use that one. Once we use this layer, it will automatically uh, include that bias also in this layer. Okay, weight and bias are contained in this layer. Okay, and finally it is sigmoid is there to convert the values whichever linear layer is giving, to convert those into probability we will use this sigmoid layer. Okay, the sigmoid function mainly gives values between 0 and 1. Okay, so our model is defined here. So as you can see in our image input layer, then we have this linear layer. Linear layer means this we will estimate using that linear layer this W1 and W2 plus and B. These W1, W2 and B contained in this linear layer. Okay. For this one, this part, we have this line. Okay. And for this part, we have this line. Yes, sigmoid is a predefined function which is contained in this NN library. Okay. So our model definition is here and we have defined the single layer perceptron model. So anybody who previously not knows the neural network, you can understand these are very simple. We are uh, we are stacking those layer using the sequential function, and these in this stack we have linear and one linear layer and a sigmoid layer, whichever present in this diagram. Input layer is the only our input data. This portion, for this portion W1, W2 and B will be contained in this linear layer, and for this one we have this sigmoid. Okay. Once we have this is the equation of sigmoid, it gives the values between 0 and 1, which we will consider as the probability of pass and fail. Okay. So as we have used yesterday, we are using these binary cross entropy loss and optimizer function as SGD. So using this binary cross entropy loss, we will calculate the error. As I told, some prediction value we have got, and we have the input value. Input value like this one. We will calculate how much error are there, and based on that one, we have to update this. Based on that error, we have to update this weight to get new weight. So how we will update? We will update some small, adding some small value or subtracting some small value. Okay. To get new weight, we will add some small value with this W1, or add or subtract some small value with the W1 and W2. So that small value, how much small value we will add or subtract, that is defined by this parameter in that um, uh, SGT. This is called learning rate. Okay. So basically, this amount we will increase or decrease based on that error. We will increase and decrease with that weight. Okay. So there is some mathematics, partial derivative are there to calculate whether we will add or subtract. I am not going into that detail. Uh, just uh, uh, just think that that is SGD for now. For now, like SGD is the black box, and we are giving a learning rate. Learning rate means how much value, how much constant we will add or subtract from these weights. Okay, I am repeating. So we have got the prediction in forward pass. Okay, once we got that once we got that values using in forward pass, next we will calculate the error based on whatever values we are getting and what is our input, and based on that error, based on that error we have to update these W1 and W2. Okay, so how we will update? We will add suppose we have a small number that is 0.01. We will add that 0.01 with W1 and W2 or subtract that one based on that error. So that 0.01 is called learning rate. So means little bit, I am going little bit deeper. So suppose this is the error function. Okay. So loss function, error function means loss function. Now we have to reach here. We are now here. Okay. So suppose we are how much we will go in this side, we have to calculate using we have to decide that one using that learning rate. Okay, suppose we have taken a big value of LR, learning rate. So and we are subtracting, we are here, we are subtracting that learning rate from this point. Then for big value it came here. Again, uh, again we have calculated the error, and we have calculated, we have decided no, we have subtracted, now we have to add, then it will again come here like that. So if you make learning rate very high, then it may toggle here, it will not reach this optimum point. We have to reach this optimum point. So uh, based on using that LR, we can reach that one. But if we set this LR value is very small, then it will take too much time to reach here. Suppose we have run that, training for 2000 epoch. Learning rate is very low. It came from here to only here. this much, then this 2000 epoch is not sufficient. Okay, so this is a mm, whenever you will train a model, you will usually all researcher or whoever implements, they use that point zero 0.01 or 0.001 like that. Okay, the value of learning rate. Okay, so some more sophisticated optimizer function now available, which automatically adjust this learning rate also. Like Adam optimizer also learn this learning rate also. Okay, so here we have used that SGD, stochastic gradient descent, as optimizer. So here we have to give that learning rate. Okay, now we can we will train that model. We are running for 200 epoch, as it is very um, small data, so it just millisecond it get trained. So we got this model, trained model, using single layer perceptron. Now we want to test for new values. Our study hour is 6 hour, and that study hour is 6 hour, and attendance is 78. So it is pass probability for this single layer perceptron, as it is very small data, it is giving probability 1. Surely it will pass. Okay. So I think today all of you understood how this simple neural network is, and single layer perceptron, how it is that much simple. Okay, I think all of student got understand this simple neural network. Okay, you can implement, means you can add more layer here and you can get some result. Okay, so whenever you will add that more layer, it will become multi-layer perceptron. Okay, as I told here, so in single layer perceptron, that were only one calculation. Here we have two calculation, one hidden layer calculation, one and one output layer calculation. Okay, so in MLP, multi-layer perceptron, it became more complex than single layer perceptron. So it takes more time to train multi-layer perceptron. But what happens, as we are getting more parameter here, more weight value here, more bias here, so it will predict much better than that single layer perceptron. Okay. So again, I am repeating a little bit here. Input layer are there. One hidden layer is there with 3 neuron, only 3 neuron. You can increase that number of neuron here. And one output layer is there. Finally, to get the probability, mm, we uh, use that sigmoid function to convert those output to a probability. So in this hidden layer, we will use another thing. This is called activation function to impose some non-linearity. Otherwise, it will if we do not imply that one, it will uh, just uh, mm, just create a linear function. Okay. If we get that, if we estimate the linear function, that will not solve a complex problem. Uh, to solve a complex problem, uh, we need to add that non-linearity. Okay. So from input layer, it will just multiply matrix multiplication. It will do with that input to weights to get the value of hidden layer, and after that again it will apply activation to get these values. Whatever activation it is giving, after activation whatever value is it is getting, it will uh, multiply with another weight v1 v2 v3 suppose, and another bias, it will add another bias, it will get output layer. Once output layer we will get, we will apply that sigmoid function, and if we apply that sigmoid function, we will get the probability. Input layer is the same. Input layer, whatever input layer we have used here, that is same as here. Just for weight matrix, we have to calculate all the values for this neuron. We have that weight matrix W11, W12, W13, and W21. It is W22, not W23. This is W23. Okay, we will do that matrix multiplication with this X1 to W1, W2, W3, whichever is there, and uh, with the weight matrix, another matrix multiplication will be there, and we will get that hidden layer. Okay. So, in implementation perspective, this input is that x as that input, and we will add a linear layer for hidden layer. After that, we will use that ReLU or any other activation function, and another layer for our getting that output layer. Okay. So see here, we have stacked to this one for this hidden layer, and this one for that activation function, which is applied or output of this hidden layer, and after that we have added another layer. Suppose this part is same as um, single layer perceptron. So this part is the for another layer, hidden layer. So typical MLP looks like this, but you can add more layer to get more complex network. Okay, so if we define this one, that model, we have defined a MLP with one hidden layer. Then again, we have considered that SGD as optimizer function, and whatever uh, mm, binary cross entropy loss we have used in single layer perceptron, called we have used same. Okay, this one we have defined in single layer perceptron. It is defined above. Okay, this one. Now our MLP is again trained today also with two features. Now if we do that prediction for um, same test, whichever we have used is in single layer perceptron, we will get the prediction probability for um, fail probability, probability of passing the student. It is 1. So, as it is very small data, so it is giving that much high probability, means it is uh, well trained. It can means it perfectly fitted a curve to predict to tell the value of pass, whether student will get passed or failed. Okay, so this is very simple. You can implement your own any complex network. If you draw a image like this, after that you just add some layers. Many type of layers are there. You have to add those, means whether what activation function you will use, and how many neurons you will use. Here I have used 5 neuron in this um, network. ReLU is a activation function. Okay, it has an expression. You can it just, if less than 0, then it makes 0. Whatever value it comes, suppose after this linear layer, you got a value. If it is greater than 0, then it keeps as it is. If it is less than 0, then it converts to 0. Okay. So up to this, we have completed yesterday, and I taken 1 hour more to explain those, but it benefited you because how this MLP looks like, how this single layer perceptron looks like, I have explained, so that you people can um, implement your own in PyTorch. Okay. Now I am going into, I have already shared this file. Again, I am sharing. For any complex neural network architecture, you have to draw a figure, draw a image like this. Then that will be yes, you can use that sigmoid function as activation function. TANH you can use, ReLU you can use. Based on that experiment, what will give you better result? You have to do that experiment, and then you have to decide. Just you cannot say this will give a good result. That is also true for how many neurons you will use. That is also not initially you cannot predict. You have to learn. Uh, if you add much very large number of neuron or large number of layers, then what happens? It will overfit the data. What it means suppose you have 1 lakh data, and you need all these, you can count how many parameters are there, including these weights and this bias and all these things you can count. Suppose for example I am saying you have 64K parameters. You often hear about that these large language model has 7 billion parameter, or this has 60 billion parameter. Like that you can count the number of parameters. So based on that parameter, suppose you have taken a large number of parameter with large number of hidden layer, uh, uh, and your data is small, then what it will happen? It will overfit. What it means? Whenever a model is overfitted, it will uh, give high accuracy with the test data. But when unknown data will come, it will not give a good result. Overfitted happens like that. So whenever you will implement that model with your own, uh, you have to consider how much data you have. Based on that data, you have to do experiment with number of parameters. So if your data is very large, and your number of parameter is very low, it will get underfitted. So it will not give a good result. But if you have a large amount of data and you have considered a very large amount of parameters, then you may get a good result. But whenever that large number of parameter you will consider, it uh, problem comes uh, that computation capability of your machine. Whenever that large number of parameters are there, that computation, it required very high computation, and it requires very high volume of GPU, like that. Okay. So based on your requirement, you have to decide, not only requirement, based on your requirement and your computation power, you have to decide how much large amount of parameter we will consider. Okay. Okay. So I'm moving to that clustering. So till now, what we have learned? We have learned regression and classification model. So for these two, those are supervised training, because here we have supplied the label of each data. Label means whether the student got failed or passed based on the input value, we have that one. Now suppose um, we have data. I'm sharing this one. This is uh, notebook for clustering. So I think we can cover um, k-means clustering only, but if we get time, we will go for DB scan also. Okay, here also I have created a empty notebook and I'll learn that one, run those, copy and paste and run those. Yeah. Okay, so I'm giving a brief overview of unsupervised learning. So previously, whatever example we have taken, whatever means that student data, we have that label. Now, suppose we do not have that label. We have student data, we have attendance, we have study time, but we do not have that um, whether uh, the student got passed or failed. Okay. So in that case, how we can group those students, means um, whether we can consider this group will get failed and this group will get passed. Okay. Another example, suppose we have large amount of emails, email data, but no label are there. Now we have to consider whether which one is spam and which one is not spam. So we have to group that. Same as like this. Suppose uh, mm, uh, we have uh, one data is there, image data called mnist. mnist mnist. So in this data, it contain handwritten numbers from 0 to 9. 10 class is there. So suppose it has about 70k data. So now suppose we do not have that um, um, level of those data, or so it is suppose we have Google Photos, many photos are there. Now we want to group those photos, so we don't have that label. How we will do that one? That is the problem. That is called unsupervised learning where we don't have any label. So this grouping is called clustering. So most popular clustering method is K-means clustering. So what it does? What it does? I'm creating, taking a new page here. Okay, what is that orientation? Okay. So suppose we have data, those data, here is the data, hour of studies and attendance. We don't have this um, uh, label here. Now we want to do that grouping of this data. Okay. So K-means clustering is there. This function is there in sklearn cluster. Okay. From there, we can use that K-means clustering. So I am loading this one. All other libraries you know already. Now suppose this is the data. So here you can see this hour of study is there and attendance is there. Based on this two feature, we have to group those students. Okay. So here we are plotting. Okay, we have plotted that one. Now, what we will do? We will apply the K-means clustering from uh, sklearn library. Okay. So same thing as we have did earlier. We have called that clustering K-means clustering. Uh, Here is the definition, and after that we have trained using this fit function. Okay. So here, while calling this K-means clustering, we have to uh, provide how many clusters are there. Okay. Here we have provided that we have only two clusters. Another is This parameter you can give or you can ignore that one. What it means, uh, in k-means clustering, it start from random value. Okay. So if you want to reproduce the result, then you have to give this random state, which random value it will start, from which random value it will start, it will decided by this. Okay. Now we have fitted with that data frame our data set. Now if we want to see the clusters, you can see this one. With this label, you can see this. So we have created two clusters here. One is 0 class and another is 1 class. So from data, you can see first 4 data and um, before last, that was in same class. Okay. So if we plot this, KNN is another algorithm I have not explained here. K nearest neighbor, it searches that neighbors. Okay, I am not completed the k-means yet. Okay, so this is the clusters we got. This portion goes to one cluster and this portion goes to another cluster. So what it does, suppose we have data here, like this we have data. Now what k-means clustering does, it does, it makes clusters. Okay, so what actually that algorithm does, it initially it consider some uh, centroid value. Suppose we have two cluster, here it considered, here is one centroid and another one is suppose here. So what it does, it randomly choose two centroid. This is the first step. After that, it will assign each point to that. Suppose this is one cluster centroid and this is another cluster centroid. Now this is cluster 1, C1, and this is cluster 2, C2. Now for each point, it will calculate the distance between a point and centroid, and it will assign that point to that cluster, which has minimum distance. Okay. For each point, it will do the same. It will calculate distance from centroid to that data, and it will assign the cluster value based on that distance. Whichever is minimum distance, it will goes there. Okay, it assign there. So for each point, we have assigned a cluster. Means this one goes to which cluster, this one goes to which cluster, this one goes to which cluster we have assigned. Now suppose this portion here got in this cluster and this portion got this cluster. All points should have goes in some cluster. Suppose this points goes in there. In second iteration, it will calculate in first iteration this C1 and C2 are random value. In second iteration, it will calculate the new centroid. Okay. How it will calculate? It will take the average of those points. So if we take average of these points, then we will get another centroid, like suppose it's shifted here. Suppose we have pink color, it shifted here in second iteration and it shifted here. These 2 points are, these points is the average of all these points belonging to this cluster, and these points is the centroid of this cluster, which is calculated by taking average of all these points. Okay. Thus, we have got a new centroid which is calculated from those data. This is not a random. Okay. In the same way, we again calculate the distance of each point from this centroid and assign those to that one cluster which has minimum distance. Okay. For each point, we again calculate the distance and assign that point to a cluster, new cluster. So from this, some points may goes in this cluster, from whichever that was in old cluster, it can goes new cluster based on this new centroid point. Okay. In this way, we repeat suppose few iteration, and after few iteration, if those centroid are not changing, then we can stop. If sometime it happens, we cannot get that much, then we have to define a tolerance value, and we will check whether those centroid values are not changing that much tolerance value. We can stop, or we can consider like suppose 100 iteration we have pre-decided, we will run for 100 iteration, and whatever centroid it is giving, we will consider that as our intended centroid. Okay, I think all of you understood this. So for this part, someone asked, why are we doing this iteration? As I told, initially we have considered random centroid. This C1 and C2 initially here we have considered random centroid which are not true centroid. Okay. Over the iteration we will recalculate the centroid and we will assign the points based on that centroid value. So for this reason we need iterations. For each iteration, this centered value will get changed. Once it get changed, that cluster assignment will also get changed. So again, cluster assignment changed means again we have to calculate that new centroid. Like that, in each iteration, we calculate the new centroid and we assign all points to a cluster. That is the basic algorithm, main algorithm. Okay. Final cluster, someone asks, sir, so final cluster is based on which centroid? Final cluster is based on last iteration, whatever iteration, last iteration is there. Based on that iteration, you are calculating the centroid. That is the final centroid. And there may be the situation that centroid are not changing. That is the final centroid. Okay. So here I have plotted the centroid. This is the centers after training. This is 2.4 and 45 and 6.6 and 78. And if we plot that one, you can see the centroid. These are the centroid of this cluster. Here we have got this cluster and this cluster. This is the centroid of this cluster. It is this one, 2.445, and this is the another centroid. See, if it is someone told so convergence is possible. See, if it is well separated, if your data is well separated, suppose here it is well separated, then convergence will happen. But if it is not well separated, then um, uh, it may not converge, but it will give some value. Then you have to give some number of iteration or a tolerance value, that if this much error we get, then not error, we can say this much change of centroid is happening, we will consider this is the final. Okay. So here I have considered it has suppose 3 cluster, then what happens? I have plotted here. I have changed number of cluster as 3, and what is happening here? Here it predicted 3 cluster. Okay. Now, as I have told, suppose some customers are there. Customers segmentation means suppose Amazon review are there. We want to uh, we want to group those customers based on that review, product review, based on product review or based on purchase practice. We want to group them. We can do that one because it a thousand millions of customers are there. uh, we can use without label. We can use those customers data to group. Another example is friend recommendation, like Facebook friend, Facebook Meta uses that clustering algorithm, using that graph data. They will cluster that's those graph data, and who is the maybe the friend, he can request, you can send suggested friend. Okay, so you people can change the cluster here. I have already done that one, and you can see this one. Okay, so till now we have learned very popular three algorithm. One is regression, another is classification, which is supervised learning. Another we have learned is unsupervised learning. So I have kept whatever algorithm I have um, just explained. Using that, I have wrote a little bit large program. It is not uses that sklearn library, but it will show you the animation how this clustering is happening. So here suppose we have these data points. Okay, now these are the data where we have um, uh, just predefined the data. We have considered 100 random numbers around 444, around the point 44 point, and another 100 numbers around 65 points. Okay, now initially we have randomly chosen 1 8 and 8 2 as initial centroid. Okay, here is the initial centroid 1 8 and 8 2. Now you can see what is happening here. Based on that initial centroid, it calculated the distance and it assigned the clusters. So whichever is closest, it assigned those to that cluster. So these points are closest to this centroid. It assigned into this cluster, and these points are closest to this centroid. It assigned to this cluster. It is first iteration is over. Okay. In are those points center point of those cluster? Are those points center points of those cluster? Devajyoti, I could not get to your question. If you are asking whether these random points are belong to the data points, if you are asking that one, that may happen, or you can random number. You can consider from that data points, or you can consider any number, but the dimension should be same. Okay, that is a random number. So, uh, as I told, in first iteration, it assigned these points to this cluster based on as distance from this centroid it is closest. So it assigned here, and here it assigned to this cluster centroid. Okay. Now in second iteration, what is calculate the new centroid? How you will calculate? It will take the average of these points. Yes, I am. Someone asked how we know which data point belong to which group. That is, I am saying based on that distance, we will calculate which data points goes to which group. Whichever is based on this centroid, we calculate. We have this centroid and this centroid. We calculate the distance from suppose from this data to this centroid we calculate, and this data to this centroid, and based on the distance, whichever is minimum distance, we will assign to that cluster. That is the logic. Simple logic, but very powerful logic. Okay, so uh, after assignment, we have to calculate the new centroid. Here we have calculated the new centroid by taking average of these points. These are the new centroid. So in second iteration, we got this new centroid. Then again we have to assign those points to the uh, to new clusters, to form new clusters. Okay, so I could not get the points you are asking, Mandila. You can connect later, okay? Because I have to complete. Okay, so what I was saying, okay. So we have got the new centroid. Now we have to assign all those points to based on the new centroid to form new cluster. So we have done that one. Here you can see the points changed from this to this. Those points actually came to this cluster. These points. Okay. So in second iteration, this assignments procedure is done. So in third iteration, we do the same. Again, we will take the average of these points, and we will calculate the new centroid. Okay, in uh, um, whatever he is asking, I don't know if it is if he is asking like that, some points distance, suppose distance is same from both the centroid while assignment, we are doing assignment if uh, distance from both points are same, both centroid distance from both centroid is same for a particular data point, then we can assign that data point to randomly to any cluster. Okay. Now assignment is also done in second iteration. We have calculated new centroid. Once we have calculated the new centroid, again we have to assign those data points to form new cluster. That is the assignment procedure. So after three iterations, see, centroid is moving, but no new assignment. After four iteration also it is moved, but then after some iteration it will not change. Okay, I have kept here 5 iteration. Here it is, there's iteration. I have kept 5 iteration. Uh, yes, if distance are same for a particular point, over the iteration it will goes into correct cluster. Okay, when you are recalculating the centroid, so actually question is if we assign those points in a randomly to the cluster, if distance are same, then that may lead to wrong labeling. For that particular uh, iteration, it is labeling as distance are same. Human beings also cannot say it will go which cluster. It will also goes into same cluster. Mm. It will also goes into random cluster. But whenever you are calculating new centroid, then that time also new centroid came. Then if you calculate the distance, it will not will be the same, because new centroid is not the same as previous. Okay. So we have this is the algorithm whatever I have just mentioned. This is the implementation. Here we have taken the centroid. Now suppose we are doing some another experiment here. You also can do. Suppose we have added another centroid 8,8. Then what is happening I can see. Here we have considered 3 random centroid initially. Okay. Now it is calculating the it is assigning a new centroid based on those random centroid. It is assigning the clusters. Again, it is based on that clusters. It calculated the new centroid, and when we got that new centroid, it again form new cluster. Okay. Like that it happens. This is the loop. This is the for loop where this new centroid calculation and assignment is happening. Okay. So I think all of you learn this K-means clustering also. So in these 2 days, we have learned unsupervised learning, learned supervised learning, and regression. Okay. Now another popular uh, algorithm which often used is DB scan, because as in K-means clustering, uh, we have to provide that how many clusters are there. Often it happens we cannot estimate the actually how many clusters are there. For DB scan, we do not need to provide the uh, mm, number of clusters. Instead, what we have to give, we have to provide a two parameter. What is two parameter? One is um, the epsilon value, means minimum distance. Another is in the cluster how many minimum value will be there, minimum sample will be there. These two we have to give. Okay, I am running this one in our new notebook. Okay, suppose this is a new data which do not have that label. This is attendance and hour of studies. Here is the data. See, here we have intentionally kept this 18 hours studied, but got 40 marks. So this is outlier. So uh, in in this data set, in this technique has this technique has the capability of finding outliers. Okay. So we have called that dbscan function, which is imported from sklearn library, and we have provided the epsilon value. uh, Epsilon value is the maximum distance between uh, mm, 2 points in that cluster, and minimum number of sample present in that cluster. Here we have kept that 2, and we have fitted that fit predict. We have used that one. It will fit and also predict on that data. Okay, and if we plot, we can see This one. See, it created two cluster and one outlier. So how this DB-scan algorithm works? Uh, what it does, yeah, what it does, suppose we have um, some points here, here, here. Okay. So all those points are initially non-visited. It consider all those points are non-visited. Now start from a non-visited point and you calculate the distance, uh, calculate the point, get the points which are less than that epsilon value. Epsilon is given in that parameter as parameter value. Uh, get those points uh, mm, which are less than these, those points which distance from that point is less than epsilon. Means suppose our epsilon value is 4, here suppose it is 1 unit, it is 2 unit. So this point, this point, this point, all those point goes to uh, neighbor of these points. Now, if those number of neighbors is greater than that minimum, uh, greater than that minimum sample, then we will call that as a core point. Okay. So if we get a core point like this, then we will expand that cluster to form a cluster, to expand those cluster to form a new cluster. How we will expand? We will calculate from this point also the distance, and whichever is within this epsilon distance will come into that cluster. And if um, some points have um, have this distance from this cluster is less than 4, but it does not have the minimum count of neighbors, then that will be called boundary. Suppose here it is connected to this because its distance is less than 4, but suppose those points are not there, only 2 points are there, only one distance is less than 4. So in that case, the minimum number of neighbors criteria is not matching, so it will become as neighbor, it will become as boundary of this cluster. Once it is completed to form that cluster, we will again go, we will consider new non-visited points. Suppose Here it is, which is not visited. For that point, again we will calculate the neighbors, number of neighbors, and number of neighbors, and um, if it is core point means if its number of neighbors is greater than minimum number of neighbors, which is given as parameter, then we will expand that cluster also. Okay, in this way we form clusters, and whichever data has less than minimum number of neighbors clusters, that data point is will be called outlier. Okay, so here one cluster we got, we will choose this one, and we will consider that whether which points are in that epsilon neighborhood, and if it is greater than 4 greater than 2, then we will again consider all other points also to form a new cluster. Once this cluster we have formed, then we will go for new cluster. And here you can see it has no neighbor, so it is the outlier. Okay, for this one also I have kept a animation here. We can run whatever logic I have told just now. I have implemented here. Okay, and you can see it is started from one non-visited point. Now it is calculating the epsilon neighborhood. Sorry. Within that epsilon neighborhood, it is calculating the points and forming the clusters. Okay. Like that, it is forming the cluster. Now it is last, it is not, it is not visited. Then it is trying to form a cluster here with minimum number of data points. It is not there in its neighbor, so it is the outlier. Okay, so someone asks some question. What what impact does initial centered have on that model? How to choose optimal initial? Uh, is it Dipan? Is this question for clustering or what? I could not understand. You can choose any number of cluster based on your requirement. Okay. So, are there any other form other than epsilon neighborhood? Uh, as I know, in DBScan, this epsilon neighborhood is that used in DBScan. Other form, I don't know whether it is there or not. Someone asked, are there any other form other than epsilon neighborhood? I don't know whether there is any other form. Whatever I know, that is epsilon neighborhood based. Okay. So I think you have learned supervised, unsupervised clustering. Sorry, supervised, unsupervised learning. If you have any doubt, you can mail me. Yesterday, I gave you that mail ID, and we'll share whichever project we will share, that will also contain these supervised, unsupervised, uh, may not be for all, but and that project often happens in disjoint format. So mainly these algorithms will be there. You have chance to do yourself. So you can use those library if you want to learn more. You can implement yourself. You can enjoy implementing. But if you want to learn very well, don't use that Chat GPT or Gemini like that or Claude, because if you use those, you cannot learn those concept or those programming. So try yourself; it will be good. Okay, I am concluding. If you have any question, you can mail me. I will reply, try to reply. Okay. Today, I am finishing here. If you have any question, you can mail me. Okay, thank you.
Thank you, Chananda.
Okay.